G'day team, welcome back to another video. So today we're going to continue on with our logarithms, but last time we kind of just focused on logs in base 10. What we're going to do today, we're actually going to extend that to the log of base of any number a, okay? So we can use the same principle as log in base 10 of b to define logs of different bases. So the logarithm in base a of b is the power that a must be raised to in order to obtain b. So here we've got a nice little if and only if statement. So a to the power of x equals b if and only if x equals the log of base a of b. Okay, so this is our exponential expression, this is our log expression. So we can jump between the two, and that's what we're actually going to practice right now. So just so we have it, I'm going to duplicate it and bring it down for us to use down here. All right, so write an equivalent exponential statement for log in base 2 of 8 equals 3 and log in base 3 of root 27 equals 1.5. So write an equivalent exponential statement. So we're given it in this form, we need to write it in this form. So we're just taking what information we need. So my a value in this first expression is 2. All right, my x value is 3, and then that is equal to 8. Which is my b value, which is a correct statement. 2 cubed is indeed equal to 8. Same process we're going to use for part B. So my a value is 3. That's what my log is to the base of. My x value is what the whole thing's equal to, so 1.5. And then we've also got the b, which is what it's equal to, which is inside the log, which is the square root of 27. Now, if you did that on your calculator, you would see that that is in fact true as well. All right, let's grab this guy again because we're going to use him. Hopefully I've got all of it. Yep, beautiful. So we're going to bring him down to here now because we're going to use him to write equivalent logarithm statements. Okay, so now we're going from this form across to this form. All right, so we've got 2 to the power of 6 equals 64. Now, what I like to do, I like to write log straight away. Then my a value is 2. All right, so we put 2 there. My b value is 64, and then that has to equal x, which is 6. Okay, same process here that we've got here. So 2 to the power of -1 equals a half. So I write to like to write log first. My base is again 2. And then we've got a half as my b value, and that has to be equal to my power, which is in fact -1. Okay, all right, so that's how you go from equivalent logs statements to equivalent exponential statements. Okay, so you can flip between the two. It's really good to practice as well. Just another couple of examples. So simplify. So I remember yesterday, well, last video, we were talking about log of base 10. When that's got a 10 to the power of something inside the log, then it's just the power. So same thing applies with any base. So if we have, for example here, log of base m of m cubed, see how the base and this number in here are the same. So the same logic applies. That is just equal to 3. All right. B is a bit trickier. We need to put 1 on a squared in terms of a power of a. So log of a, base a, of a to the power of -2, so our negative index law, and that is just equal to -2. All right, simple as that, exactly like we were doing in the last video with bases of 10. Same thing applies with any base whatsoever. All right, with that, have a crack at some questions through the textbook, wherever you can find them. Practice these skills as they're really, really important and will carry us through the rest of this topic. We'll see you guys in the next video. Thanks for watching.